this video, I'm going to show you how to use Desmos. So Desmos is essentially, it's a free online graphing calculator, and it's pretty user-friendly. So just to start out with, looking at the different sections, here in this section we have the different axes, and this is where we're actually going to put our plot, and essentially it looks like graphing paper. Now one thing to notice here is that we can toggle either zoom in or zoom out to have different axes. Over here on the left, this is where we're going to plug in what it is we actually want to graph. So to start out with, we had the example in the notes on page 5 where we were looking at f of x, and we wanted to find the limit of f of x as it approached 1 if it was squeezed between the functions 1 and x squared plus 2x plus 2. So let's see how we can do this. So up here first, I'm going to put in our first function, which was x squared, squared plus 2x plus 2. And so you'll notice here, now we have the plot of that function. Now one thing that I will note, to get the x squared, how I actually typed that in was on my keyboard. I typed the letter x, and then above the number 6 on your keyboard you'll see a caret, or it looks kind of like an upward arrow. That was the next character that I typed in, and then the number 2. And so you'll notice that when I did that, it doesn't actually show that character here, but it does place it up top. Now you could also click down here, and this will open up a little keyboard that you can use. And so alternatively, what I could have done is typed in the letter x, and then I could have used this a squared. That will put it up top. And then again, we had plus 2x plus 2. Either way, it will draw the function. And then if I want to, I can click and drag. Maybe if I want to see more of this, we could zoom in, we could zoom out. So we could look at that different ways. But for this particular example in the notes, we were looking at this function compared to the function where we just have y, or f of x, is equal to 1. Now I do need to be careful, because if I just type in the number 1, notice that nothing happens. So when our function is a constant number, we need to do one of two things. So we could have g of x is equal to 1, and notice that will draw the function here. Or, when I remove this, you could also do y, since really g of x is going to take place along the y-axis, is equal to 1. But either way, we get what we want. Now I kind of like using the g of x is equal to 1, and then we can click here, toggle it on and off, and so we've got some different options there. Now, what I'm going to do next, turn that down, is I am going to zoom in, because if you'll remember for that example, what we were interested in is we were interested in finding the limit of f of x as f of x approached -1, and remembering that f of x was sandwiched between these two different functions that we have just drawn here. And so we can see at -1, both of these functions, their limit is equal to 1, and so here we were able to prove that the limit of f of x was also equal to 1. Alright, so let's look at just another example on how we would do this in Desmos. Oops, sorry, I scrolled in. I need to reset my computer there. There we go. So the other one that we looked at was the sine of x divided by x. So again, I'm going to delete these off. And here I'm going to do my first function to be sine of x divided by x. And so here is what that function looks like. And then if you'll remember from the notes, what we were able to show is we were looking at the limit of sine of x over x as x approached 0 and showing that that was equal to 1. What we did was we used the sandwich theorem, and we were able to show that this function was sandwiched between 1 over the cosine of x and cosine of x. So let's actually add those in and see what that looks like. So first, here we have the cosine of x. And then next, what I'm going to do is have 1 divided by the cosine of x. All right. And we can see that when x is equal to 0 and that we are approaching 0 from either side, we can see that the function we're interested in, which is the red function, is in fact sandwiched in between the blue function and the green function, and that the green function, as it approaches 0 from either side, approaches 1 and has a limit of 1, and so does the blue function. So therefore, even though the function we were interested in, the function in red, does not exist at 0, it still has a limit equal to 1. And that's exactly what we showed in the notes. Right, so again, you can just close those off. And so in your homework is going to ask you to use a graphing calculator to sketch different graphs. So instead of doing that, what I would like you to do is instead to use Desmos. And in particular, this will be for 17, 18, and 19. And you'll notice for 19 in part B asks you to use a graphing calculator to investigate the values of x, and then it's going to give you 3 different functions. Well, you'll be able to create these 3 different functions in Desmos just like I did, and you can explore that graph to see what the limit is. Now, in order to put these graphs or to save these graphs so you can submit them with your homework, what you can do is if you click this button right here that says Share Graph, you'll notice that one of the options is Export Image. So if you've been handwriting your homework, one option that you can do is you could print off a page that has that plot on it and then continue writing on that page and then upload that file. If you've been using your iPad, you can just put that image directly into what you've been doing. But that way you can export this image that you create here and then use that to answer your homework questions. Now, of course, if you have any trouble with Desmos, you have any questions on that, please let me know, and I'm more than happy to help.